Hey, Math 110 students, we're continuing on discussing inverses. And let's just review a little bit here of what we talked about up to this point, just in terms of graphing inverses. So if I graph, let's see, let's turn, zoom, let's do 6. All right, let's graph this equation. This is x to the third. We're going to reflect it across the line y equal to x. And the inverse is a reflection across that line. So the inverse, let's say for this one, you had the 0.13, then your inverse will have the 0.31. The x's and the y's are flipped. That's why it's a mirror image across this line, y equal to x. All right. So that's graphically. Then in terms of just the algebra, what happens is that an inverse function undoes the original function. So the one that I just showed you right here on our graph was x to the third. Okay, it was x to the third and x to the 1/3. Okay, x to the third and x to the 1/3. So let's think about that for a minute. All right. If f of x is x to the third, and then its inverse, f inverse of x is x to the 1/3. Okay, well, let's think about it. All right, what is f of 2? Okay, that's 2 to the third, which is 8. Okay, so that's the domain, that's the range. All right, now let's put the range in this one. So f inverse of 8 would be 8 to the 1/3 power. This is the same thing as the cube root of 8, but you can just put it in on your calculator like that. 8 to the 1/3 power is 2. So what you see is happening here is that they undo each other. If you put in 2 into the original and get out 8, you can put the 8 into the inverse and you'll get back out the 2. Started with 2 and you end with 2. They undo each other. Okay, they undo each other. All right, so that's what we're talking about here with these guys that are inverses of each other. And let's go from this slide right here. All right. Remember that the domain of the original function will be the range of the inverse. The range of the original function will become the domain of the inverses. And we want to know is, let's see, inverses will undo each other. So if you put x in the first and then whatever answer you get in the second, you should just get x back out. All right, so let's verify that g of x is x to the 5th and its inverse is the 5th root of x. Well, how would we do that? All right, well, let's find g of g inverse. Okay, g of g inverse or g inverse of g. G of g inverse, g of g and g inverse of g, either way. So if we'd start with the inverse of g of x, this is going to be the inverse of x to the 5th. That's g of x. And the inverse function is the 5th root of x to the 5th. And the 5th root undoes raising something to the 5 power. And so you do get x out. These are inverses. And vice versa. G of g inverse would be g of the 5th root of x, which would be the 5th root of x to the 5th. Same thing. 5th root is undone by raising something to the 5th power, and you just get out x. All right, how about b? These are both straight lines, okay? All right, so here you want f of f inverse. So we're going to plug in 1/4 x plus 7 where we have an x here. All right. That's this one. Plug in 1/4 x plus 7 where you had the x. Multiply it out. That's 1. Comes x plus 7. Those cancel out. So x plus 7 minus 7 is just x. And vice versa. 1/4. Plug in the f of x and that one, 1/4 times the f of x plus 7. That's just 4x. So 1/4 times 4x is x. They do indeed undo each other. And another way to look at these is you can graph them. Let's graph both of these and we'll show you that they're inverses graphically as well. They're reflections across the line y equal to x. So the first one I had, I'm going to keep my line y equal to x, was x to the fifth. Okay. And then its inverse was x to the 1/5, or the fifth root of x. Under your math, actually I can do this another way. Math. All right, see right there, number 5, the x root. All right, so I need to put in 5, and then 5. The x, the x root of x. All right, let's see if this does this. All right, there's x to the fifth. We're going to reflect it across the line y equal to x, and here is the fifth root of x, and you do see that those are inverses of each other. All right, the other ones that we had, the second one was 4x minus 7. That was the first one. And then the inverse was 1/4. So I'll put that in parentheses, 1/4, parentheses, x plus 7. These are both just straight lines, but look, if this is your first line, there's your line y equal to x. The other one is a reflection across y equal to x. They were inverses. All right, so what if I want to find the inverse of a function? All right, how do I find it if I do not already know it? And it's a very, very simple process. Very simple process, okay? To find the inverse of a function, we're going to take the original function. So for us, it was f of x equals 3x minus 5. All right, and the inverse will flip the x and the y. Right now, f of x is your y. This is y equals 3x minus 5. We're going to flip the x and the y. So for our inverse, we're going to flip the x and the y, and we'll get x equals 3 times y minus 5. And then you need to solve for the y. So I add 5 to both sides. So y equals x plus 5 over 3. So how would I say that then? I would say the f inverse of x is going to be x plus 5 over 3. This is the function that will undo that function. F of f inverse would just work out to be x. All right, let's go back to our PowerPoint. And if you graph both of those lines, you would see that they do cross their reflect across the y-axis. So the procedure for finding the inverse of a one-to-one function is you just flip your x's and your y's. I think this is too wordy. You just flip your x's and your y's and you solve. All right. Now, this one's going to take a little bit more work because it's a rational function. So let's do it. But we're just going to have to think about it a little bit harder. Okay. All right. So what's our original function here? Our original function is f of x. Oops. Let's get a little bit wrong. Our original function is f of x equals x plus 1 up top over x minus 2. And we were told x cannot equal 2, which makes sense. So that would give us 0 in the denominator. That's the problem. So this is our y. Our y equals x plus 1 over x minus 2. And to find the inverse then, okay, the inverse, we need to flip our x's and our y's. So I'll do my inverse. All right, so now I've got x equals y plus 1 over y minus 2, and I need to solve for y's. Oh, well, how do I solve for y's? Well, let's get them all up top. Let's multiply the top and the bottom by y minus 2. Okay. Oops, can you see that? So I'm getting it out of the denominator here. So on the left, I've got x times y minus 2x. And on the right, I've got y plus 1. Okay. X times y is xy. X times negative 2 is negative 2x. Then these canceled out, y plus 1 up here. Get all your y's on one side. So xy minus y over here. I'm going to put my 2x over the other side, positive 2x plus 1. Factor your y out, x minus 1 equals 2x plus 1. Okay, and then solve for the y. So my y, therefore, is going to equal 2x plus 1 divided by the x minus 1. All right, this is my F inverse. So F inverse of x is 2x plus 1 over x minus 1. X cannot equal 1, because that would make it undefined. All right, this is the inverse function of our original f of x. All right, now you can pause this and rewind that if I went through that too fast for you. All right, now back to our PowerPoint, which they did it too. They checked them both. All right, how about find the inverse of x squared plus 1 if x is greater than or equal to 0? Why are they saying x greater than or equal to 0? Because it has to be 1 to 1. This one's not 1 to 1 for all real numbers. But if you just let x be greater than 0, greater than or equal to 0, then it will be 1 to 1. Okay? All right, so let's look at this one. I'll go back over to my scratch paper. We'll go to new screen. I mean, the new page. Oh, not that page. All right. So we've got f of x equals x squared plus 1. Right, so this is our y. Y equals f of x. And our x is restricted to the positives. X greater than 0. So the inverse, so let's find the inverse. Like we're going to flip our x and our y. So now I've got x equals y squared plus 1. All right. So let's subtract 1 from both sides. That's going to equal y squared. We're going to take the square root of both sides, and we get y equals square root x minus 1. I believe for this one, we are only going to take the positive root. We're only going to take the positive root. That'll be your inverse then. And this is what, because we restricted the domain of the original to the positives, then our inverse is still a function, okay? All right, so basically, if a function is 1 to 1, then it can have an inverse. The domain of the regular will be the range of the inverse. The range of the initial will be the domain of the inverse. To verify that they are inverses, you plug one function into the other, and if you get x out, then it is a true inverse. And then the graphs of the inverses will be symmetric with respect to the line y equal to x. And our keyword for today is inverse. Inverse. Use your Ask My Instructor button if you have any problems, and or call me at 268-2516, or email me, email me the keyword inverse to alsopwh@octech.edu. We'll see you later.